In this session, we're going to look at inscribed angle theorem. But first of all, we need to know what inscribed angle is. So by definition, inscribed angle is the angle formed in the interior of a circle when two chords intersect on the circle, or it is an angle formed by the common endpoints of two chords. So if you have two chords with a common endpoint, the angle formed by that common endpoint is called an inscribed angle. So let's look at the diagram. Okay, as you can see, we have many chords here. So if you look at chord KD and chord LD, this is the common endpoint. So the angle formed is called an inscribed angle. So delta, this is an inscribed angle. Also alpha, look at chord MN and chord PN. They have the same endpoints N. They have the same endpoint, so this is also an inscribed angle. So look at chord AG and chord FG. So the common endpoint is G. So beta is also an inscribed angle. So look at chord J, I and chord F, I. So theta is also an inscribed angle. So finally, look at GF and IF. F is the common endpoint. So this angle is also an inscribed angle. So any angle formed by two chords with common endpoint is called an inscribed angle. So let's look at inscribed angle theorem. Okay, inscribed angle theorem, it states that the central angle is twice the inscribed angle. So if you look at this diagram, you can see that theta is the inscribed angle because C is the common endpoint of AC and BC, the chord AC and chord BC. So the theorem states that the central angle must be 2 times the inscribed angle. As you can see, we have theta, we have 2 theta. Or, because theta here is an acute angle, that's why the central angle is like this. If you look at this, you also see that beta is an inscribed angle. So G is the common endpoints of AG and BG. Therefore, the central angle 2 beta. Do you see? So it's an obtuse angle because beta is an obtuse angle. So that's it. Let's prove the theorem. Okay, look at the proof. We added an auxiliary line CD. So the line divides the inscribed angle into x and y. So the inscribed angle is x plus y. That's the sum, x plus y. So want to prove that the central angle is 2x plus 2y. Yes, because since we've divided this into 2 isosceles triangle, this is the radius of the circle. That's the distance from the center to the vertex. As the vertex is one of the points on the circumference. So we have 2 isosceles triangle, and we know from isosceles triangle theorem that the base angles are congruent. So that's why here is x, here is x, here is y, here is y. So, and also looking at this, we see that this is an exterior angle. So using exterior angle theorem, x plus x is 2x. And also using the exterior angle here, y plus y is 2y. So have you seen that the total angle is now 2x plus 2y, which is the same as 2 times x plus y, which is 2 times the inscribed angle. So we've proved that. So let's look at this question. Using inscribed, this is the center of the circle. Conventionally, when the center is O, we normally denote a circle with center O. So this is the center of the circle. So from inscribed angles, you see that the central angle, which is 3x, you see that 3x must be equal to 2 times x plus 10, which is the inscribed angle. So why? Inscribed angle theorem. So from here, this is 2x plus 20. Therefore, x is 20. So that is option A. We are asked to find the measure of angle ABC. ABC, look at what we are looking at. So let's call it theta. So what do you have to say? You will notice that angle ABC is the inscribed angle, while this is the central angle. So from here, 257, O, angle at a point is 360. So this remaining angle will be 360 minus 257. So since this is the inscribed angle, theta will be half of 103 by inscribed angle theorem. But we know how we got 103, angle at a point. Okay, let's just do it before that. So we are saying that angle AOC is 103. That's angle at a point. It's always 360. So if you subtract 257 from 360, that is what you get. Therefore, theta will be 51.5. So that's our answer, option B. GO. So we are looking for this, and we know that OG and OC is the equal since the radius of the circle, and by isosceles triangle, this is also theta. Also by inscribed angle, this is now 125/2. This is the central angle, so this is 125/2. So our answer is B. But let's solve for solving sake. Let's just write. So I said that let angle CGO be theta. So therefore angle OCG is also theta. Why? Isosceles triangle theorem. Therefore angle OCG is 125. That's theta. Is 125/2 by inscribed angle theorem. So our answer is option B. This is a straight line. Using angle at a straight line, this is 180 minus x. Yes. So we are saying that angle CAB is 180 minus x. Angle on a straight line. So since we've gotten this, we can see that this is the central angle for this inscribed angle, 180 minus x. So if you add this, 28 plus 42 is 70. So this should be 290 to make it 360. So angle COB, that's for the major arc, is 290, angle at a point. Therefore, from our inscribed angle theorem, that the central angle, which is 290, is equal to 2 times 180 minus x as inscribed angle theorem. So which is, this is 1, 4, 5, 180 minus, so I divided both sides by 2. Therefore x is now 180 minus 145, which is 35. I want to relate, because here is also y, I want to relate x and y. So this is y, this is also y by, so from here we see that 2x plus y is 2y is equal to 180 degrees. So if we factor 2, I have x plus y is 180, therefore x plus y is 90. So that's why I told you that since we know this x to be 70 in this question, the base angle here will be 20. So it's always true. So it makes us to solve the question fast. Find the measure of x. As long as this is the center of the circle, if you add this angle and the inscribed angle, it will give us 90. So this should be 7 since this is 20. And when I prove inscribed angle theorem, if you add this angle with this, it will give you the inscribed angle. So since here is 5, here should be 65. So our answer x is 65 degrees, option B. The measure of angle ACO. So we are looking for this angle. And since we are looking for this angle, once we know this, we can get that. So this angle and this angle are equal by vertical opposite angle. And by a theorem that once you have an inscribed angle here, that the angle here is connected to the inscribed angle, they sum to 90. Yes, I will prove it after the solution. So 70 plus 20 is 90. So this is now 26 to make it 46, vertical opposite angle. So our answer is option A. So let me prove how I got the answer. We are looking for this angle, let's call it theta. But there's a relationship, okay, from here, this is 70. By vertical angle theorem, this should be 15. And there's a relationship connecting this inscribed angle, as long as this is the center of the circle. And this, they sum to 90, so here should be 7. If you add this angle and this must give us 90. So finally, by a stereo angle theorem, we see that theta will now be 75 minus 43 by a stereo angle theorem. So our answer is 32, option B. So it's the first one. So the only way we can solve this is to relate this angle using this and this, or using this and this. So we can get this either by adding this and this. Once this is the center of this circle, so it's theta 23 plus theta 2, or using a stereo angle theorem, which is theta 1 plus 65. So we're asked to find theta 2 minus theta 1, so which is 65 minus 23. So our answer, we'll see that this should be 120, yes, using inscribed angle theorem. So that's the first thing. And you see that OC is parallel to AD. So since they are parallel, they are consecutive. That's the angle here and here. Angle O, angle A are consecutive. So this should be 60. So finally, if we add, because we're looking for AD, they gave us AO as 3 cm. So let's add an auxiliary line running from O to D. So what do you have to say? We see that this is also the radius of the circle, so this is 3 cm. OD is also the radius, which is 3 cm. And we know that this is an isosceles triangle. As you can see, OAD is an isosceles triangle. So the base angles must be the same. So this is 60. And what do you have to say? Since this is 60, this is 60, the remaining angle of the triangle will be 60 to make it 180. So let's wipe this and partition it to 60, 60. So let's make it 60, 60. So this is 60 and this is 60. So what do you have? We see that this is an equilateral triangle. So AD is now 3 cm since they have the same interior angle. So let's just state what we've solved. So first thing is that the angle AOC is 120 degrees based on Inscribed Angle Theorem. That's the first thing. Secondly, that angle OAD is 60 degrees based on consecutive angle theorem. Length OD is 3 cm based on the radius of the circle. Which implies that angle ADO will also be 60 degrees based on isosceles triangle theorem. And since it's 60, therefore angle AOD is also 60 degrees based on angle sum theorem for triangle. So what do I have to say? AD is now 3 cm. Length AD is 3 cm. Why is it so? Equilateral triangle theorem. So that's it. That's option A. Okay, welcome back. In this particular session, we're going to learn a theorem called Thales theorem. So the theorem states that the inscribed angle of a semicircle is 90. Yes. To see a semicircle, you know that the inscribed angle of that semicircle must be 90. So let's draw a diagram. As you can see, this is the semicircle. See the center of the circle. The inscribed angle is always 90. And to prove that it's correct, remember they said that the central angle is 2 times the inscribed angle. So always 180. So meaning that the inscribed angle must be 90. So I've proved that. So let's now solve question on that. So we're given this question. We're asked to find the measure of theta. So look at the theta. And I'm seeing the diameter. So since here is 180 degrees, our inscribed angle must be 90. So this is 90. So we'll have a right angle triangle. So I'm saying that angle ACB is 90 degrees based on Thales theorem. Therefore, theta is now 27 degrees based on angle sum theorem for triangle. Angle sum theory for triangle. So triangle sum to interior angle sum to 90. So this should be 27. So it's very simple. Option C. Option C. So look at the next question. Said if angle ACD is 120.5, then we're asked to find angle BCD. So BCD, let's call it theta. We're asked to find BCD, which is theta. But from our Thales theorem, I'm seeing a semicircle, so this is 90. So I'm saying that angle ACB is 90 degrees. Why? Thales theorem. Need to tell them why. Is geometry. So since that, theta will now be 120.5, since the total is 120.5. So 120.5 minus 90, that's the remaining angle here. Since they told us ACD is 120, so the answer is 30.5. So that's option A. The next theorem is Boyle's theorem. Boyle's theorem states that inscribed angles with the same intercepted arc are congruent. So let's draw a diagram. So as you can see, let's see inscribed angle ACB. So the intercepted arc, look at intercepted arc AB. Are you seeing it? A, that's this arc, A to B. So that's what we call intercepted arc. The arc that forms the inscribed angle is called intercepted arc. So look at this. So the inscribed angle is theta. So that same intercepted arc will produce D, angle D. Do you see it? That same A, B. Also look at E. Do you see that same arc? So the theorem is telling us that once they have the same intercepted arc, the inscribed angle must be equal. That's why it's theta, theta, theta. So let's look at the major arc. Do you know these minor arcs? So let's look at major arc AB. That same AB, but major arc. So let me use ADB. That's major arc. This is minor arc. So that is also an intercepted arc. So you notice that inscribed angle G, that's beta. This is AGB. This is beta. That same major arc AB gave us this beta again, H. Also I. Do you see? So the theorem is saying that once they have the same intercepted arc, they must have the same inscribed angle. So let's prove it. Okay, to prove that, we locate the center of the circle O. So from here we can get the proof. We can prove that. So what do you see? That angle AOB, which is the central angle, will have three answers depending. So if you take angle ACB to be the inscribed angle, so you see that this angle AOB will be 2x. Yes, based on inscribed angle theorem, that the central angle must be 2 times the inscribed angle. So the first one, we took angle ACB to be the inscribed angle. So let's take angle ADB to be the inscribed angle. You see that that same angle AOB will be 2y based on the same reason. And also if you look at AEB, the inscribed angle is also 2z. So what do you have to say? 2x is the same as 2y and is also the same as 2z. Therefore x must be equal to y and it must be equal to z. So we've proved that once they have the same intercepted arc, they must have the same inscribed angle. So let's solve the equation. As find the measure of x plus y degrees. So as you can see, you see that AB is our intercepted arc. So this is the intercepted arc. So look at the inscribed angle. Have you seen it? So which is 30 for the so 30 degrees is the same as what? 2x. Also the same as 3y. So what do you have to say based on this is based on Bose theorem. Therefore, or which implies that x will be 15 degrees, y and y will be 10. That's equating 30 to 2x, x is 15, 30 to 3y, y is 10. Therefore, x plus y degree is now 25, which is option C. So it's simple. Let's solve another one. So we asked to find the measure of theta. So we'll combine two theorems here. Yes. So the first thing, I'm seeing a central angle here and a diameter. So what comes to our mind is Thales theorem. But we don't see a triangle, so we need to complete the triangle. Let's add an auxiliary line running from C to B. Yes. So this auxiliary line makes the solution easy, because from here you see that angle ACB will be 90 degrees. Yes, based on Thales theorem. And since this is 90, angle BCD will now be 123 minus 90, which is 33 degrees. And since we know angle BCD, this is an intercepted arc. This is an intercepted arc. So you see that this angle, let's call it theta, will be the same as this. Yes, since here is theta, here is theta, based on what? Bose theorem. So therefore, theta will now be 33 degrees based on Bose theorem. Bose theorem. So which is option D. So it's a tricky question, but it's easy. We're asked to find the values of x and y. Okay, the first thing we'll see here, this is the central angle. Yes, we'll combine two theorems now. We use inscribed angle and also Bose theorem. So we'll see that x plus y 60 degrees, y angle at a point. Yes, since this is 300, the remaining is 60. And since this is 60, this angle should be 30. Yes. Since angle AOB is 60, angle ADB will be 30. Why? Why? Inscribed angle theorem. And since this is 30, it should be equal to this because this is an intercepted arc. So this is our intercepted arc. AB is the intercepted arc. So we see that x minus y will be equal to 30 degrees. Why? Bell's theorem. So we have a simultaneous equation. This is equation 1, this is equation 2. So we eliminate y by adding equation 1 and 2. So if you adding equation 1 and equation 2, we see that 2x will be equal to 90, which implies that x is 45. And also we can eliminate x by subtracting. So if you do equation 2, or maybe equation 1 minus equation 2, we see that 2y will be equal to 30. Therefore y is 15. So x is 45 and y is 15. So let's solve another question. So we're asked, what is the measure of theta? So to solve this question, we apply what we've learned so far. So as I'm seeing angle, you can see that angle ABE is 13 degrees. So meaning that this angle by Bell's theorem, this is also 13 degrees. So I'm saying that angle EDA is what? 13 degree. By which theorem? Bell's theorem. And since what I've said before, there's a relationship connecting this angle, or maybe this with the inscribed angle here. They always sum to 90. So since this is 47, this should be 43. I've done that in my previous video. So if you sum this angle, I'm saying that if you have okay, we're asked to find the measure of JFG. So let's call it theta. By Bell's theorem, this is also theta because we have the same intercepted arc GH. So again, there is a theorem. This is also this is 130 degrees. Yes, by vertical opposite angle. So there is a theorem in geometry that if you have anything like this, basic geometry, that the angle here, if it's theta 1, this is theta 2, this is theta 3. And if you add theta 1, theta 2, theta 3, it will give you theta 4. So I'll say that theta 4 is theta 1 plus theta 2 plus theta 3. Therefore, you see that if I add theta plus theta plus 50 must give us 130 degrees. Yes, so we have 2 theta is 130 minus 50. 130 minus 50, I have 8. Therefore, theta is 40 degrees. So it's a tricky question, but it's easy. So option C. Okay, in this session, we'll be talking about cyclic quadrilateral theorems. So, but before then, we need to know the meaning of cyclic quadrilateral. And by definition, a quadrilateral inscribed in a circle is called a cyclic quadrilateral. Let's use a diagram to explain that. Okay, look at this diagram. A quadrilateral is a four-sided polygon, as you can see. So if you inscribe a four-sided polygon in a circle, we'll have a cyclic quadrilateral. And remember, it must inscribe means it must, the vertices must be on the circle. So this is a cyclic quadrilateral. The first diagram, maybe let's call it A. The second one is also a cyclic quadrilateral. As you can see, all the vertices, the four vertices are on the circle. Finally, the last one is also a cyclic quadrilateral. So no matter the shape, once it's a four-sided polygon, it's called a cyclic quadrilateral. So let's look at the theorem on that. Cyclic quadrilateral are supplementary. The theorem is telling us the opposite angles of a cyclic quadrilateral sum to 180 degrees. That's it. That's supplementary. So let's use a diagram. Okay, we have a cyclic quadrilateral and we have two pairs of opposite angles. As you can see, vertex A is opposite vertex C, while vertex D is opposite vertex B. So the theorem is telling us that angle A plus angle C must sum to 180, while angle B and angle D must sum to 180. So that's it. So the next thing is to prove the theorem. Let's prove it. Two auxiliary lines, one running from center O to vertex A and the other running from center O to vertex C. So we have that. So as you can see, we have the two opposite angles B and D. We see that from our inscribed angle theorem, we have two angles here, two central angles, AOC, and also that same AOC. One is the major arc, while the other one. So the major arc is ADC. That's the major arc, while the minor arc is AC. So we have this angle and this angle. So as you can see from our inscribed angle theorem, this one, the major arc will be 2B. As you can see, this is 2B. So AO, this is 2B, while the minor is 2D. So this is also 2D by inscribed angle theorem. So we now have angle at a point. This is D. Therefore, we have angle at a point. So if you sum 2D and 2B, it must give us 360. Angle at a point. And we can see that we can factor 2. We'll factor 2 on both sides. That's dividing both sides by 2. I have D plus B will be 1/8. So do you see it? That if you sum the opposite angles, you will get 1/8. That's supplementary. So look at this question. We are asked find angle D. Without wasting time, you can see that angle D will be 150. Yes, because 30 plus 150 is 180. 8. So it's very simple. By opposite angle of a cyclic quadrilateral. So always remember to tell the reason. Use geometry. So you need to tell how you got the answer. Why the second question? We asked to find the value of x. As you can see, I'm seeing an inscribed angle and I'm seeing a cyclic quadrilateral. So we have two angles, this and that, that are opposite. So we see that x, we see that x plus 80 degrees plus 3x plus 10 degree must sum to 180. Yes, that's opposite angle of a cyclic quadrilateral. So as you can see, we can add now. X plus 3x is 4x. 80 plus 10 is 90. 180 minus 90 is 90. Therefore, x is 90 over 4, which is 45 over 2. So we're looking for angle ABC. Let's call it theta. Okay, let me use another ink. Let me call it, let me use red. So let's call it theta. So how do you relate the given angles? We are given this x and also we are given 4x this. So what do you have to say? Let me use white. From here you see that theta will be x over 2. Yes. Why? Based on inscribed angle theorem. And also if you add x over 2, that's theta, plus 4x, it must give us 180 degrees based on opposite angles of a cyclic quadrilateral. Yes. Do you see it now? We have a cyclic quadrilateral and we have that. So if you add this and theta, theta is x over 2, we have 180. So this is 9 over 2x equal to 180 and 9 20, so x is 40. But we are not asked to find x, we are asked to find theta, which is x over 2. Therefore theta is 20, 40 over 2. So that is the answer. We would say if A and B are the centers of the circles, find y in terms of x. So we're making y the subject of formula. But looking at the diagram, you can see that you can observe that one of the centers of the circle, which is the blue circle, is on the circumference of the red circle. So I will add two lines, auxiliary lines, running from D to B and also from E to B. So do you see the line? So what do you observe? I now have a cyclic quadrilateral FDBE. So we can relate, because that's the only way we can relate x and y. So I'll need to bring in this angle, which is now the connection between this x and also y. So from what we've learned before, so we know that y, we can relate x and y, that angle DBE, this angle has two values, either is equal to 2y by Inscribed Angle Theorem, or is equal to 180 minus x by opposite angles of a cyclic quadrilateral. So this is the only condition that we can relate x and y. Implies that 2y is equal to 180 minus x. So if we make y the subject of formula, we see that it's 90 minus x over 2. So that's our answer, option B. We're asked to find theta. As you can see, since this is theta, it should be 180 minus theta, yes. Based on, so I'm saying that angle, okay, let's call this AC, we omitted B, let's call here P. So angle BAC is 180 minus theta based on opposite angles of a cyclic quadrilateral. And also that same BAC will be 180 minus the sum of 23 and 81, yes, based on angle sum theorem for triangle. So the interior angle always sum to 180. So what do you have to say? This is that same angle BAC is this. Therefore you see that theta is 23 plus 81, which is 104. So that's our answer, option B. We are asked to find z minus y. So as you can see, this is a cyclic quadrilateral. We say that x plus y must give us 180, and also 135 plus z will also give us 180. So what do you have to say? Based on opposite angles of a cyclic quadrilateral. So what do you have to say? We can equate x plus y to 135 plus z. Yes, since the both sum to 180, so you can equate the two. So we are looking for z minus y. So making z minus y the subject of formula, this is z minus y, which is this same as x minus 135. So this is it. This is option A. From the diagram, you see that theta will be gotten using cyclic quadrilateral theorem, yes. So because theta is this, if you look at ADEB, is a cyclic quadrilateral. So once I know this angle, the total angle, and the total angle here, I've known what I'm looking for, theta. So first of all, let's get angle ABD. So from here you see that angle ABD is 30 degrees, yes, using both theorems. Look at the intercepted arc AD. So it will produce this angle and this, so they are equal. So, and if you look at this, for me to get this, I'm seeing a triangle, that's EDF, and I'm seeing an exterior angle. So using exterior angle theorem, you see that this should be 46. Yes, if you sum 30 and 46, it gives you 76. So our answer is already there. So let's state what we've done, because you need to tell them how you got your answers. So first of all, we say that angle ABD is 30 degrees. Why? Bose theorem. And that angle FDE is 46 degrees. Why? Exterior angle theorem. That's a triangle theorem. So finally we can get theta. How do you get theta? It should be 1/8. That's if you sum this. So let's do, let's just do it normally. Theta plus 46 is one of the angle, that's the vertex angle, plus 30 plus 50 must give us 1/8. Why? Opposite angles of a cyclic quadrilateral. So that's supplementary. They sum to 1/8. Therefore, theta, this is 80, 100. So theta will be 100 minus 46, which is 54. Okay, we ask what is angle ACD. So from the diagram, you see that ACD is this angle. And how do you get this angle? The easiest way is to get this. Yes, because AEDC is a cyclic quadrilateral. So we use cyclic quadrilateral theorem. And how do you get this angle? We can get this. So the first one is this angle AEC is 23 degrees. Yes, using Bose theorem, this is 23, the same intercepted arc. So they'll have the same inscribed angle. And how do I get this? Using inscribed angle theorem. This is the central angle, so this should be half of 8, which is 43. And how do you get this angle? We can get this using cyclic quadrilateral, that the sum of this is supplementary. So our answer is there already. So the first thing we'll notice is that angle AEC is 23 degrees based on Bose theorem. So that angle CED is 43 degrees. Why? Inscribed angle theorem. Angle theorem. Therefore, ACD should be 180 minus the sum of 23 and 43. Why is this so? Opposite angles of a cyclic quadrilateral. So that's supplementary. So that's what we are looking for, angle ACD. So our answer is, this is 7. So this should be 114. Yes, because this is 66. 66 minus that is 11. That 180 minus 66 is 114. So that's option C. So what was the measure of theta? Okay, that's what I'm asked to find, but I'm given 42 degrees. So how do I relate 42 degree and theta? So the best way, since I'm seeing the diameter running from D to B, and also I'm seeing this line, if I add an auxiliary line, it will make my solution easier. So let me add an auxiliary line running from E to D. You see that the equation is solved. So I've added that, and I have a triangle whose hypotenuse is the diameter. And since because for me to get 42, for me to relate 42 degree and this, if I add this and this, it will be 180 based on cyclic quadrilateral. So the equation is already solved. So I'm saying that angle, the first thing I did is getting inscribed angle DEB, which is 90. That's this theorem. Therefore, if I add 90 and theta, it will be the same thing as, that's 90 plus theta is one of the angle here. Is now one angle, plus 40 plus 42 degrees will now give me 180 based on opposite angles of a cyclic quadrilateral. Therefore, theta will now be 180 minus 90 is 90. 90 minus 42 is 48. So that is our answer, option B. So we use two theorems to solve this. Look at the theorem 2. Under cyclic quadrilateral, it states that the exterior angles of a cyclic quadrilateral are congruent to the opposite interior angle. So let's use a diagram. So look at this diagram. So we see that we have exterior angles here. So we are saying that if here is theta 1, the interior angle here, while the exterior here is theta 2. If you have an interior theta 3, while the exterior here is theta 4. If you have interior theta 5, the exterior here is theta 6. Finally, if you have interior theta 7, the exterior here theta 8. So we can relate each interior and the exterior. So we are saying that theta 1 is equal to theta 2. That's what the theorem is saying. Theta 3 is equal to theta 4. Theta 5 is equal to theta 6. And finally, theta 7 is equal to theta 8. So interior equals opposite exterior. So that's what the theorem is saying. So let's prove it. Okay, look at this. Let's just use one and prove. If I call this theta 1, so let's know whether is equal to theta 2, which is this. So from our cyclic quadrilateral, that's the first theorem, we know that angle ADC will be 180 degrees minus theta 1 based on opposite angles of a cyclic quadrilateral. So that's supplementary, as you can see. Let's just write it. This is 180 minus theta 1. So, and as you can see again, this is a straight line. AG is a straight line. So you see that 180 minus theta 1 and theta 2 will sum to 180 degrees based on angle on a straight line. So what do you have to say? 180 gone, 180 gone. So we see that theta 1 is equal to theta 2. So we've proved that. So let's look at this easy question. We are asked to find x minus y. So we are seeing a cyclic quadrilateral ABCD, and we are given interior and exterior angle. So we see that y plus 10 degrees will be equal to, should be equal to x minus 5 degrees based on what? Exterior angle of a cyclic quadrilateral. So that equal So this is equality sign. So we're asked to find x minus y. So y goes over to be here to be x minus y. y5 goes here to be 10 plus 5. So x minus y is 15. So that's a fast one, very easy. We're asked to find the measure of A. So without wasting time, I will solve fast and I will show you how I got it faster. So once I have this diagram, to solve it fast, A, as the angle here, is related to this angle and this angle. Angle 20 degrees and angle is always equal to 180 minus their sum over 2. So from here, this is 70. 180 minus that is 110 over 2. So this is 55. So our answer is option B. So it's fast, but let me tell you how I got it fast. So to prove that, we want to prove that I told you that A is equal to 180 minus the sum of E and D over 2. So that's what I used in solving the equation. So as you can see, this is a cyclic quadrilateral AFHD. So this is theta. Okay, this is A, sorry. This is A, not theta. And again, look at this triangle AED. By a stereo angle theorem, we see that this is A plus E. Yes, A plus E is this. So we now have a triangle with interior angle A plus E and D. So we can solve that. So I'm saying that angle DHG is A based on opposite angles of a cyclic quad, and angle EDG is A plus E based on a stereo angle theorem. Therefore, if you add A plus E and D, it will give us 180 degree. Why? Angle sum theorem for triangle. So as you can see, remember we're looking for A plus A is 2A. So I have 2A equals 180 minus E plus D. Yes, plus E plus D goes over to that side to be minus E minus D. Therefore, A is now 180 minus E plus D over 2. So that's the formula I use in solving the equation first. We're asked to find angle RPS. Since this is A, I'm seeing a tangent line and I'm seeing an inscribed triangle. So this should be A also by alternate segment theorem. And also I'm seeing two parallel lines, ROX and UT. So this should be A by alternate angle theorem. So with that, we are asked to find an angle RPS. RPX, which is this. So we now have a complete angle on a straight line. So let's solve. Let's just state. So first, we'll notice that angle PRS is A by alternate segment theorem. And angle RPO, that's this RPU, is also A alternate angle theorem. Therefore, the angle we are looking for, which is angle RPS, will now be 180 degrees minus 2a. Why? Angle on a straight line. So that's our answer. Option C. Find the measure of angle PQX. Without wasting time, let's add an auxiliary line running from Q to R. So I have this auxiliary line. Since I'm seeing a tangent line here, so this is 65 degrees based on alternate segment theorem, and also this is 55. Yes, based on that same alternate angle theorem. So our answer is 120, option B. But let me now state so that it will be formal. So the first thing I discovered is that angle RQP is 65 degrees. Why? Alternate segment theorem. Also, angle QPR is 55 based on that same alternate segment theorem. Therefore, the angle we are looking for, which is angle PQX, is 65 plus 55, which is 120. So option B. We're asked to find the value of y. We should find the value of y. So as you can see, I have two circles. So since I have a tangent line here, this is 70 by alternate segment theorem, and also this is y. This is a tangent line AF, so this is also y by alternate segment theorem. So what do you notice? We have a triangle CAB, interior angle 50, 70, while we have exterior y plus 47. So the answer is now simple. The answer is 73. But let's solve formally. So I'm saying that angle CBA is 70, y alternate segment theorem so angle FAD is y, the same alternate segment theorem. Therefore, y plus 47, that's the exterior angle, is equal to the sum of 50 and 70, y exterior angle theorem. Therefore, if we solve for y, we have 73. So y is 73, option B. That's to find the measure of angle SQR. So we are looking for SQ. So once we know this angle, we add it to 63. That's what we are looking for. But before we can get this one, we need this, because from alternate segment theorem, this is 42. So using an angle and a straight line, we'll get this. Finally, we'll add it to that. So from here, we see that angle UQS is 42 degrees. Y alternate segment theorem. Therefore, we see that angle TQX will now be 180 minus the sum of 63 and 42. Y angular on a straight line. So which is 180 minus, that's 180, this 180 minus 105, which is 75. Therefore, what we are looking for is angle SQR, which is 75 plus 63. The answer is 138. So option C. To find what is the measure of theta, so look at theta, and I have 3 theta here. So first thing I notice that I have a tangent line, so we need to use alternate segment theorem, but there is a little problem here. We don't have an inscribed triangle. Yes, because for you to use alternate segment theorem, you need a tangent line and also an inscribed triangle, such that one of the vertices of that triangle is the point of tangency. So we need to add an auxiliary line. So let's add. So I've added an auxiliary line. Let me call it this A. Okay, let's call it B, from C to B. So we have a complete triangle now, an inscribed triangle. So what do you have to say? You see that this is 3 theta, yes, based on alternate segment theorem. This is 3 theta, this is also 3 theta, and as you can see, this is the center of the circle O. So using inscribed angle theorem, which says that the central angle is 2 times the inscribed angle, so this should be 6 theta. So finally, we now have, okay, before the last step, this is the radius of the circle. As you can see, this is the radius, and we know that radius is always perpendicular to the tangent line. So this is 90. And finally, we now relate this remote interior angle 90 and theta with the exterior angle 6 theta using exterior angle theorem. So we are done with the solution. Let's just state the process. So the first thing I notice is that angle CBA or O is 3 theta. Is 3 theta. Is that angle AO, that's the central angle, angle AOC is 6 theta. Y inscribed angle theorem, as the central angle is 2 times the inscribed angle, and angle OCF is 90 degrees. Y radius tangent line relationship. So they're always perpendicular, always. So finally, we'll see that 6 theta is the same as 90 plus theta based on what? Exterior angle theorem. That's the sum of remote interior angle equals exterior angle. So from here we see that 6 theta minus theta is 5 theta. So theta is 90 over 5, which is 18 degrees. So this is our answer, option B. So asked to find angle CDA. So let's label it angle CDA. So let's call it, that's it, that should be theta. And if you look at the angles given, we need to relate it to the one we are looking for. I'm seeing a tangent line and I'm seeing an inscribed triangle. So once you see an inscribed triangle and a tangent line, what comes to your mind? Alternate segment theorem. So this is 97 degrees. So, and I'm seeing, as you can see this line AB is parallel to DC. So since they are parallel, DA acts as a transversal. So this should be theta by corresponding angle. So we are done. So we can finish up the solution. So we see that angle D or angle CAD is 97 degrees based on alternate segment theorem. And that angle BAE is theta based on corresponding angle theorem. Therefore, we can get the answer now. So if we sum, therefore theta will be 180 minus the sum of 97 and 29 based on angle on a straight line. So our answer is, the answer should be 54. Yes, this is 126, so theta is 54. So it's a nice question. So we asked to find the measure of angle ABE. So let's call it ABE, let's call it theta. So we see that angle CBA is 90, yes, because I'm seeing the diameter of this circle. And angle CBF is 23/1/2 based on alternate segment. This is a tangent line and this is an inscribed triangle. So this angle and this angle are equal. So finally we can solve our equation. So we have that the first thing I noticed is that angle ABC is 90 degrees based on Thales theorem. And that angle CBF is 23/1/2 based on alternate segment theorem. Therefore, we see that theta will be 66.5. Yes. Because if you add this angle on a straight line, that's a straight line. FE is a straight line. So that's our answer, option B. So let's look at it. They said if angle BCD is 4 times CDF, then the measure of CDF is dash. Okay, so what I will do, I will call, let angle CDF be theta. So let's call it theta. Therefore, angle BCD D will be 4 theta as given. So let's go to the diagram. So as you can see, I'm seeing a cyclic quadrilateral, and also I'm seeing an inscribed triangle and a tangent line. So from here we see that this angle should be 30 degrees, yes, by alternate segment theorem. So let's write it down before we go to another one. So that angle GDA is 30 degrees based on alternate segment theorem. So let's still go back to the diagram, and we called CDF to be theta. So let's call this theta. CDF is theta. And BCD will be 4 theta. So this is 4 theta as stated in the equation. So from this, and since this is a straight line, GF is a straight line, once I get this, with that we can get theta. And how do you get this? You see an additional information. Are you seeing these parallel lines? AD is parallel to BC, and we know from our consecutive angle theorem, if you add angle ADC and angle DCB, it will be 180 degrees. So I was saying that this should be 180 minus 4 theta, because DC acts like a transversal. So this is a transversal. If you add this and this, it gives us 180 based on consecutive or allied angle theorem. So we see that angle ADC is 180 minus 4 theta based on consecutive angle theorem. So with that, what we are looking for, we can get it. We'll see that if you add, therefore if you add 30 degrees, 180 minus 4 theta and theta, it must be 180 degrees based on angle on a straight line. Therefore theta 180, this is minus 3 theta goes there, so theta will be 10 degrees. That's 30 over 3. So our answer is option A. Find the measure of angle PQN. So we are looking for this. Let's call it theta. Looking at triangle PGQ, we know that if you add the remote interior angles, that is, if you add this and this, by exterior angle is now theta. Yes. So by exterior angle, once we add these two, and from the diagram, we see that P will be 70 degrees. Yes, based on alternate segment theorem. See, this is 70, this should be 70. And by Bose theorem, if here is 13, this is also 13. So without wasting time, theta, therefore what we are looking for, theta is now by exterior angle 70 plus 13, which is 83. That's option.
A and B are the centers of the circles as shown. If angle LA is 53 degrees and angle IKH is 16 degrees, we have to find theta. So from the diagram, this is theta. But there is a theorem that if you have a circle and you have a cyclic chord, that's the quadrilateral inscribed in that circle such that they are divided, as this cyclic quadrilateral is divided into two triangles. So assuming here is theta and here is beta. So we know that theta plus beta is 1/8. Yes, theta plus beta is 1/8. Again, if I can get this angle, so if here is theta 1, and here, okay, let's call it beta 1 and beta 2. So if here is beta 1, and here is beta 2, while here is theta 1, while here is theta 2. We should know that beta 1 plus beta 2 will give us beta. Yes. What do you notice? Beta 1 is and beta 2 are in the other triangle, while beta is in the second triangle. Also, theta 1 plus theta 2 will give us theta. So what am I trying to say? If we know angle EAG and angle EGA, that is this angle, once we know this and that, if we know this and this, theta is now the sum of the two. So how do you get it? From here, we can remember we are given that angle IKH. So this is 16. So if this is 16, by Inscribed Angle Theorem, this is 32. Yes, that's angle at the center is 2 times the inscribed angle. And for us to get this, we need this. Yes, by alternate segment theorem. And we are also given that this angle is 53. So this angle is 53. So if we know, okay, this angle L will be 90. Yes. But this is a tangent line. The radius is always perpendicular to the tangent line. So let's just write for rightness sake. So I'm saying that angle EAG is 32 degrees, while Inscribed Angle Theorem so y angle ALA is 90 degrees. This one is radius tangent relationship, always perpendicular. The making angle AEL, angle AEL to be, that's 90 minus that should be 37. By angle sum theorem for triangles, it's always 1/8. Triangle. So since here is 53, by alternate segment theorem, so since here is 37, there is also 37. Yes. So this is by alternate segment theorem. Therefore, angle AGE will be 37. Alternate segment theorem. So from there, we'll see that therefore theta is now 32 plus 37 from what I just explained. So which is 16. And that should be option B. So it's a tricky question, but still simple. Thank you.
We are asked find the measures of D, E, and F respectively. So that is how I will solve this question, and it will be faster. So first of all, let's get the complete triangle, that's angle of the triangle. So this is 72, this is 34, which sums to 106. So the remaining angle is 74 to make it 180. Yes. So that's 180. So finally we can relate, as you can see, we have this circle inscribed in the triangle, and we still have another triangle inscribed in the circle, and the big triangle inscribed another circle. So once you have anything like that, know that this F, as if it's in the middle of 72 and 34, will be 72 plus 34 over 2. Yes, so which is 106 over 2. So our answer is 53. YD is the average of 72. As you can see, D is like in the middle of 74 and 72. 74 over 2, which is 146 over 2. So our answer is 73. And finally, E is in the middle of 74 and 34 over 2. So our answer is 108 over 2, which is 54. So these are the answers. So let me prove how I got this formula. So let's prove that. So assuming this is theta 1, theta 2 and theta 3, so we're going to use this theorem aside our alternate segment theorem. There's a theorem on basic geometry that if you have basic circle geometry, you have two tangent lines that have the same common point outside the circle, that the lengths are congruent. So I'm saying that this length, maybe if it's AB, and we'll have AC. So we're saying that AB is equal to AC. So that's the first thing we have to know. So using our alternate angle theory, alternate segment theory, we can solve. So let's solve. Let's go to the diagram. So as you can see, this length and this length are equal. So we have an isosceles triangle. Do you see it? So this angle and this angle must be the same thing. Yes. So what was it? We see that angle FEC and angle EFC will be 180 minus theta 2 over 2. Yes, based on isosceles triangle theorem. So the base angle are congruent or equal. And looking at this, you can still see that this angle, okay, let's use different ink. You can see that this angle and these are equal because this is an isosceles triangle. So what do you have to say? We see that angle ADF is the same as angle DAF. ADF and angle DFA 180 degrees minus theta 1 over 2. So therefore, we see that we have angle on a straight line that f plus 180 minus theta 1 over 2 plus 180 minus theta 2 over 2 will always be 180. Yes. So this is f plus this is 90 minus theta 1 over 2 plus 90 minus theta 2 over 2 is equal to 180. So 90 plus 90 is 180. 180, 180 gone. Therefore, f will now be theta 1 over 2 plus theta 2 over 2, which is their average, theta 1 plus theta 2 over 2. So likewise, the same logic, you can apply it for D and E. So I used for F, since theta 1 is here, theta 2. So that same logic for E, theta 3 and theta 2 is, that's their average. So that's the theorem, the formula, that's the formula I use in solving the question. EX and QS are tangent lines such that angle PSQ is 51 degrees. If R is a point on the minor arc PQ and angle RPS is 19 degrees, we're asked to find angle RQX. So what I will do, I have to draw a neat diagram first. So let's draw a neat diagram, a circle and tangent lines. Okay, we now have tangent line PX because they told us PXQ is 51. So tangent line QS and PX makes an angle that they intersected, which makes an angle 51 degrees. They said if R, let's call here Q, R's. So such that angle RPX is 19. So let me add auxiliary line RPS. So let's add it. So they said angle RPX is 19. So this is 19 degrees. And we're asked to find angle RQX. So let's add it. So let's call it R, that's this angle. Let's RQX. So let's call it theta. So to solve it, since I'm seeing these points on the, I'm seeing P, R, Q on the circumference of the circle. So what I will do, I will complete it so that I will have a triangle. So let's add an extra auxiliary line running from P to Q so that we can use our alternate segment theorems. Yes, because I need to complete it so that we'll have a triangle. With that, we can solve the question. So what do you have to say? That this angle, remember, alternate segments theory is a tangent line, so this is also theta. And also from alternate segment theory, this is a tangent line, this is 19 degrees. So with that, we'll have a complete triangle, interior angle. So we are saying that angle, so we said let angle RQX be what? Theta, which implies that angle RPQ is equal to theta based on alternate segment theorem. Also angle PQR is also 19 degrees based on that same alternate segment theorem. Therefore, if we sum 19 plus theta, that's this angle QP, plus angle Q, which is also 19 plus theta, plus 51, that's the 51 here, must give us 180 degrees based on angle sum theorem for triangle. Therefore, theta plus theta is 2 theta. 19 plus 19 is 38 plus that's 89. 180 minus 89 is 91. Therefore, theta is 91 over 2, which is 45.5. So our answer is option A. So it's a tricky question, but easy. As find beta 2 in terms of beta 1, theta 1 and theta 2. Okay, before I solve this, if we have a circle and we have an inscribed angle, okay, this is the center of the circle, that's O. So assuming we are given theta 1, this is theta 2, this is theta 3, and this is theta 4. So we should know that theta 1 plus theta 2 is equal to theta 3, as long as this is the center. Why is this so? If I partition this, if I add an auxiliary line here, we see that this small part is theta 1 based on isosceles triangle theorem, because this is the radius, this is also the radius. Why this is theta 2, or this is theta 2, so this is also theta 2 by isosceles triangle theorem. So have you seen why is theta 1 plus theta 2? Again, if here is theta 4, here is also theta 4. This small part is theta 4. Why? Isosceles triangle. The central angle is theta 2 theta 3. You see it, 2 theta 3. So if I add 2 theta 3 and 2 theta 4, it will give us 180. So meaning theta 3 plus theta 4 is 90. So whenever you add this angle and this, it gives us 90. So let's now apply the same thing here. So if you see, this is the center of the circle, this is theta 1, why this is theta 3. So this angle here will now be theta 2 plus theta 1 plus, theta 1, not theta 1 plus theta 3. That if you add this and this, gives you this. That's it. Like theta 1 plus theta 2 gives you theta. Again, we now have this. If we add this and this, it gives us 90. So what am I saying? I'm saying that theta 1 plus theta 3 plus theta 2 is 90. So based on what I've just said now, adding this and this gives us 90. Okay, so let's now, we've connected theta 1, theta 3 and theta 2. So let's connect beta 1 and beta 2. So if I add an auxiliary line, so you see that this is a tangent line. And if you have a tangent line, we added this triangle so that we can use alternate segment theory. Yes, so here is also beta 2 by alternate segment theory. Do you see here is beta 2, here is also beta 2. So we now have this triangle, this is 90, this whole angle is 90, angle E, H, angle EHF is 90 degrees based on Thales theory. Do you remember? Yeah, so all this angle is 90. This is 90. So since we have 90 here, and we have beta 2, so if I add this whole angle, this and this, it gives us 180. Yes, that's angle sum theory for triangle. So adding this and whole angle, this is now 90 plus beta 2. So since the sum to 180 implies that 2 beta 2 plus beta 1 will give us 90. Yes, since beta 2 plus beta 1 plus 90 plus beta 2 is 180. So since one of the angles is 90, so the other will sum to 90, so which is now 2 beta 2 plus beta 1 is 90. So what do you have here? I have this is 90, this is 90, therefore theta 1 plus theta 2 plus theta 3 will be equal to 2 beta 2 plus beta 1. Since this is 90, 90, so you equate the two. So we are looking for beta 2. So beta 2 now, making it the subject of formula, will be theta 1 plus theta 2 plus theta 3 minus beta 1 over 2. So there is the answer, option C. So have you seen how we connected it? So it's a very tricky question. Thank you. You know that if you have something like this, as long as this is the center, and if you have theta 1, theta 2, that here is now the sum of theta 1 and 2. Yes, if you could remember, to show is correct, if you partition this is the radius. We have two pairs. We have one pair of isosceles triangle. So this base angle is theta 1. Theta 1 here is a theta 2. So the sum here is total is theta 1 and plus theta 2. So using that logic here, we see that this angle will be, do you see the center? So this is theta 1 plus theta 3. So, and since I have, because we want to relate theta 1, theta 2 and theta 3, if this is beta, I have a tangent line. So if I add an auxiliary line running from E to H, so what do you notice? Since here is beta, here is also beta. So if I have known this, they gave us here theta 2. So once I know this, we can relate this and this. And if you look at this, the diameter of the circle. So this inscribed angle is 90. Yes, Thales theorem. So the remaining part here will be 90 minus theta 1 plus theta 3. Since the total, the angle here is 90. So what do you have to say? You now see that from exterior angle theorem, therefore, if you add beta, 90 minus theta 1 plus theta 2, theta 3 will always give us theta 2 by exterior angle theorem. So therefore, we'll see that if we move the and that's the variable to the other side, we'll see that theta 1 plus theta 3 plus theta 2 minus beta will give us 90. So moving beta this to the other side. So that's what we are asked to find, theta 1 plus theta 2 plus theta 3 minus beta. So our answer is option A. It's a tricky one. Thank you.